Hey, welcome back, students. In this video lesson, I want to go ahead and explain what radioactive decay is. In general and in brief, radioactive decay is going to be a process in which an atom breaks up into smaller parts. And it does this simply to achieve one thing. It wants to achieve stability. So when we talk about radioactive decay, this is going to be the following. Let me just go ahead and write this down for you. It's the spontaneous breakup of an atom. Now, the one thing about this, though, is when it breaks up, what you're really getting is you're going to get an atom such as this. It's going to be broken up into two parts, and these parts are going to be smaller. And one of the other things that could be released here in the process is going to be energy. Okay, so this is the general process by which this spontaneous breakup occurs, or this radioactive decay. Keep in mind that the radioactive decay that occurs in terms of this energy that's released, this energy can be a electromagnetic radiation. So that's something that you got to make sure that you understand, because this energy here is not just any kind of energy. This is what we call here the radiation. And this is one of those things that can be very dangerous for individuals, especially if they're exposed to too much of it. But in general, this is the process. You have one atom, and it's broken up into two smaller atoms, and there's a release of energy. And the reason that this happens is because this atom over here, I'm just going to go ahead and put this in yellow here. This atom here, this is going to be an unstable atom. And what it's trying to do, it being the atom is trying to achieve stability. Okay, and so in doing that, what happens here for these two, I'm talking about this one here and this one here, what it's trying to do is it's trying to achieve stable atoms. And that's what it accomplishes here in this general description that I'm describing for you here. And so let me give you some examples of what this looks like. An individual who actually studied this type of decay, you might have found this familiar, would have been Marie Curie. Back in 1896. She was very well known. She worked with her husband, Pierre Curie, and they're the ones that found radioactive elements for uranium and thorium back in 1896. So just a little bit of side information for you to know. But nonetheless, though, radioactive decay is nothing more than the following. It's when an atom breaks up into parts that are more stable. So this is a if I could go back here and clarify the statement that I wrote up above, where I said the spontaneous breakup of an atom, this is going to be the spontaneous breakup of and I'm going to put here unstable atom, because that's really what's going on. Okay, so let me show you some examples so that you can actually see this radioactive decay, so you can actually understand what we're talking about. Before I do want to make sure that I clarify one thing. Notice how I had written or drawn to here two atoms at the bottom. What I want to make sure that I clarify here is that this can be only one atom, or it could be two, or it could be more. The thing is that the original atom here at the very beginning, this big atom, is going to break up into something, either one atom or more atoms, but there's going to be some release of energy. An example of that is the following. So let me erase this here. We don't need that. And we don't need this top part over here. And we also don't need this. So let me use this top example here as a way of doing that. And so here's what we've got. Let's say that we take the following atom. Let's say that we took, using isotopic notation, we're going to take polonium-84. And polonium is very unstable, and oftentimes where you get with this polonium is that it's actually going to break down, and it breaks down into two things. It breaks down into an alpha particle, and so we'll represent that like this, and it breaks down into lead 206. This is, let me erase this a bit and put that here, 206, this is 82, and the symbol is lead. Okay. And so notice here, it does actually follow the general description that I put at the bottom. The main atom here is this one here. This atom here is unstable. It's very unstable. Polonium is radioactive. So what will happen is, in an attempt to stabilize itself, it will release a little bit of energy, and where it breaks up into two parts. It breaks up into what we call an alpha particle, and it also breaks up into a stable version of the lead. So in general, this is what we call radioactive decay. In the next couple of lessons, we're going to talk a little bit more about how we look at some of these equations that I wrote down at the very top here, which is a nuclear reaction. We're going to show you how to read this, how to balance it, and all of that. So stay tuned for that. If you haven't already done so, go ahead and subscribe, and we'll see you in the next lesson.